Hi, my name is Jashanpreet Singh Kamboj, and I am here to discuss the task 6.1C. Uh, let's go with the first question. Uh, the pseudocode starts with a sorting function, merge sort function array, which sorts the array in ascending order. Then initialize to pointer I and j, where I point to the beginning of the sorter array and j points at the end of the sorted array. N minus 1, where n is the length of the array. Now, the algorithm utilizes two pointer I and j to transverse the array. Uh, if we calculate the sum of the elements pointed uh, by I and j, if this sums uh, equals the x, it indicates that the required pair exists and it determines the pair array at the index I and array at the index j. If the sum is less than the x, it increments the I pointer to consider the larger element. If the sum is greater than x, it determines decrements the j pointer to consider the smaller elements. Uh, this process continues until I is less than j. If I is not less than j after the iteration, it means no such pair exists whose sums equals to x, and the algorithm returns the pair does not exist. Let's take an example. Take this as an example as input array containing 6 elements 5, 7, 2, 1, 9, and 0. If we sort the given array, then the sorting array becomes 1, 2, 3, 4, 5, 7, 9. Let's add I equals to 0 and j equal to 5 and x is equal to 9. Consider the values as x as equals to 9. Sum of uh, I and j array j is given by 0 plus 5 is equal to 10. So the value 10 in this case is greater than x. So we have to decrease the index j. Now in the next step, I equals to 0 and j is equal to 4. 0 plus 4 is equal to 8. Here in this case, it is smaller than x. So increase the value of I. I is equal to 1 and j is equal to 4. 1 plus 4 is equal to 9. This value is equals to the value of x. And that's why we can say that the R pair exists in the array. Let's move to the second question. Pseudocode push operation X algorithm. If the stack is empty, it means we are inserting the first element in the stack. We simply push the element x onto the stack and set y equals to x. Here y act as the current minimum element uh, if the stack is not empty. Uh, if the stack already contains element, we need to compare the new element x with the current minimum element y. If x is greater than or equals to y, then y remains unchanged and we simply push x onto the stack. If x is less than y, it means x is the new minimum element. We calculate a special value into x minus y and push the value onto the stack. We update x to y, indicating that x is now the minimum element in the stack. Now pop operation algorithm. If the stack is empty, there's nothing to pop, so we return null or perform appropriate uh, error handling. So we pop ele, uh, we pop the top element ele from the stack. We compare ele with the current minimum element phi. Uh, if el is greater or equals to y, it means the minimum element in the stack remain unchanged. We don't need to update y. If el is less than y, it means ele was the minimum element. We update y element using the formula. Uh, we are using the formula y is equal to 2 into y minus ele, ensuring that y reflects the correct minimum element in the remaining stack. Now the minimum operation. If the stack is empty, there's no minimum element return, so we return null or perform appropriate error handling. If stack is empty, we return the top element of the auxiliary stack, which represents the current minimum element in the main stack. This auxiliary stack maintains the minimum element at each state on the main stack, allowing us to retrieve the minimum element in the constant time. The time complexities are push, and all three operation is Cheetah 1. That's all. Thank you.